All right, today our objective will be to divide polynomial expressions, okay? So this is something that you guys have already done, and the first two things we're going to do are really just a review, and then the last thing we're going to talk about is called synthetic division. That is something brand new, but it is a little bit more efficient than long division, so I think you guys will like that. All right, so we are going to divide. First thing we're going to do is divide by just one term or a single term, okay? The process is quite simple. Divide each term by the monomial, okay? So real quick, this is something you guys have been doing a long time. So I'm going to divide each one of the terms in the top by the term in the bottom. So I have 9x squared divided by 3x plus 12 divided by 3x, that's 12x, and divide 18 by 3x. Now we just have to simplify each term. I'm going to go right up here. So 9x squared divided by 3x would just be 3x. 12x divided by 3x would be plus 4. And then 18 divided by 3x would be minus 6 over x. And that would be your answer. Okay? Let's pause the video. You do this one. And then after you pause it, the answer will be there. All right, so real quick, hopefully that's what you got for your answer. A minus 3b squared plus 2a squared b to the third. If you notice in the step above, I just divided each term in the numerator by the term in the denominator, divided them, and there's my answer. All right, next is long division, and that's something we've done in class already and something you guys have done in intermediate and algebra. So hopefully this will go rather smoothly for you, but it's just a good refresher. Okay, so if we're going to use long division, we are going to rewrite this thing. So it's x plus 3, and then inside is 3x squared plus 7x minus 12. Okay, and up here, I'm just going to do, what should I do? Let's go 5 divided by 63, okay? So luckily, this is the same exact process as it is when you divide by numbers, okay? So I'm going to divide by a number and divide the polynomials at the same time. So you see that it literally is the same exact algorithm, the same exact process, and hopefully that gives you comfort in knowing that you've done this a bunch throughout your mathematical career. So if we take a look here at the numbers first, you would say to yourself, how many times does 5 go into 6? And the answer is 1. Okay, and that's a question you've asked yourself forever when doing long division. Okay, but I want you to stick with me here because the question that I'm going to ask you for polynomials is a little bit different, but it's really the same exact question. Okay, so really quickly, let's just say I had 5 and 20, the two numbers 5 and 20. And I said, how many times does 5 go into 20? You would say 4, yes? Okay, now I'm going to ask you a different question, okay? But I want you to think about, is this the same question that he's asking as how many times does this number go into 20? What do I need to multiply 5 by to get to 20? And the answer would be 4, right? So guys, whether I ask how many times does this or go into a number, or I say, what do I need to multiply this number by to get to this number? Do you see that they are the exact same questions? Okay, and I would strongly encourage you to ask yourself the second question when dealing with polynomials. Okay, so when dealing with polynomials, you're going to say to yourself, okay, what do I need to multiply x by to get to 3x squared? Hopefully everybody said 3x. Okay, you need to multiply 3x by x to get to 3x squared, okay? All right, so now we're in the exact same spot we were with numbers, okay? So if you're with your number, after you did that, you do 1 times 5, which is 5, and you bring it below, right? Same thing with polynomials. You're going to multiply 3x by x and get 3x squared, and that's exactly what we wanted, right? We wanted to know what do we need to multiply x by to get to 3x, okay? So that's 3x squared. Now, unlike the number where you just had one term you had to multiply, here you have to multiply by both terms since it's a binomial. Okay, so 3x times 3 would be plus 9x, right? Okay, all right, let's go back up to the number then. After you get to this spot, you have to subtract, right? And if I subtracted 6 and 5, I would get 1. Same exact thing happens with a polynomial, okay? I am going to subtract these two things. Now, what's different than with a number is you have two terms, or you're subtracting a binomial, so you have to make sure you distribute that negative sign to both terms. So that would be a minus 3x and a minus 9. So 3x squared plus a negative 3x squared is 0. 7x minus 9x would be negative 2x. Okay? All right, let's go back up to the number then. If I went back up to the number, if you notice, I'm going to bring that 3 down next, correct? Right? The same exact thing happens when dealing with a polynomial. I'm going to bring down that negative 12. All right? Now, the whole process starts over again. So just like within a number, you're going to say, how many times does 5 go into 13? That happens to be 2. You're going to do the same exact thing with a polynomial, but in this case, you're going to ask a different question. You're going to say, what do I need to multiply what do I need to multiply x by to get to negative 2x? The question, or the answer to that question is negative 2, okay? All right, just like you would with a number, 2 times 5 is 10, right? So negative 2 times x is negative 2x, and since there's a binomial, we have to multiply it by both, so negative 2 times a positive 3 is negative 6. Okay, just like we would with a number, we're going to subtract. We got a 3 there. We're going to do the exact same thing in this case. We are going to subtract these two. So when I distribute this negative through, that becomes a positive 2x. When I distribute the negative through, that becomes a positive 6. So those go away, and you're left with negative 6 as your remainder. Okay, and the reason it's a remainder is because there is no more numbers to pull down, correct? There are no more numbers. So, so if you remember how to write a remainder back in middle school, this would be 12. And then the 3 would be the numerator, and the 5 would be the denominator. So it'd be 12 and 3/5. The same thing happens with polynomials. So you'd have, you'd have 3x minus 2, and then your remainder would be negative 6 over what you divided by, which was x plus 3. So there's your answer. All right, next one. Okay, guys, if you notice, this one is a little bit different than that first one. And the reason is because this one is missing an x term, correct? Right? So right up here in this bubble, just put need a placeholder, okay? Need a placeholder. So we are going to rewrite this. So we have x plus 1, and then inside we're going to have 5x squared. We don't have an x term, but we need a placeholder, okay? We need to still hold that place. So how are we going to rewrite this with an x term but not change the problem? Well, we just multiply x by 0. So this would be 0x plus 2. Okay, so if you notice, all of the exponents are going in decreasing order. So this would be a 2, you'd have a 1 here, and this would be a 0. Okay, you need that every time. If you don't have that, you need to make sure you put in some placeholders. Okay, and we're going to do the exact same thing we just did in the previous example. What am I going to multiply x by to get to 5x squared? Well, that would be 5x. Okay, so 5x times x is 5x squared, and then 5x times 1 is 5x, right? Now we're going to subtract. So let's do that. Subtract these two. Distribute my negative. So this would be a negative 5x and a negative 5x squared. So if I add that, that'd be 0. This would be negative 5x squared, negative 5x plus 2. Okay, and I'm going to bring down that plus 2 then. Okay, and now I'm just going to do the exact same thing. I'm going to ask myself, what do I need to multiply x by to get to negative 5x? And that, my friends, would be negative 5. Okay, and negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. Okay, again, I'm going to subtract. Distribute that negative through, so this would be a plus and a plus. So my remainder would be 7. Okay, so my final answer would be 5x minus 5 plus 7 over what I divided by, which was x plus 1. All right, here we go. Last part of the video, we are going to talk about how to divide polynomials using synthetic division. And I think it might seem tricky at the beginning because it is a new algorithm, but I will tell you it is 10 times more efficient than using long division. Okay? So if you follow these steps, you repeat these steps, you'll get the right answer all the time. It's just we have to practice these steps so they get ingrained into our head. Okay? So the steps are written above, and I might not necessarily use those exact words, but we are following those same exact things. Okay? So the first thing that I am going to do is I am going to rewrite all of the coefficients of the dividend. Okay? So we have a 2, a negative 13, a 26, and a negative 24. Okay? All right, next, what goes in this box right here is going to be the solution of this factor, okay? So pretend, and the reason I'm using solution is because, guys, we're going to use synthetic division a lot when solving polynomials, and guess what's going to go in this little box here? It's a solution. So I'm just trying to use words that hopefully will connect in later little sections that we go over, okay? So if this were a factor, let's say in a quadratic, right? And you had x minus 4, right? And if we were going to solve that, we would do x minus 4 is equal to 0, yes? Okay, and in order to solve for x, you would add 4 to both sides, so you get x is equal to 4. So that solution is going to go right there in that box. Does that make sense? Okay, all right. After that solution goes in that box, we are next going to bring down the first coefficient under the line. Okay, so that was a 2. So 2 goes below the line. Okay, after that, I am then going to multiply these two guys right here. Okay, when I multiply 4 and 2 together, I get 8. Okay, and 8 is going to wind up right underneath the second coefficient. After I bring that 8 up, I'm now going to add these two together. Okay, so I'm going to add these guys together. Okay, and when I add them, I will get negative 5. And you guessed it, now we have another number under the line. And what happened? What did we do when we had a number underneath the line? We multiplied 4 and 2. We're going to do the same exact thing. We're going to multiply 4 and negative 5 together, and we are going to get negative 20. And where does that negative 20 go? Right underneath the next coefficient. Okay? Once we get there, we have to add these two together. So that would be a 6. And you guessed it, if I have another number underneath that line right there, I'm going to multiply those two things together. Okay, so 4 and 6 together, multiply to give me 24. I'm going to rewrite that in the same color. I'm going to bring it up. That's 24, right? If I add those two things together, I get 0, do I not? Okay. And you guessed it, guys. Since 0 is our last digit here, this is the remainder, okay? All right. And it just so happens that in this particular case, we don't have a remainder. So the answer to our division problem would be this: 2, negative 5, and 6. Since all we did was deal with the coefficients when we were dividing using synthetic division, it should make sense that our answers, all we get are the coefficients of our answer. Does that make sense? Okay, it's our job now to determine what are the degrees. Well, let's do this real quick. If I'm dividing an x to the third by x, right? So if I had x to the third and divided it by x, what do I get? I get x squared, don't I? So what do you think is going to go here? X squared, x, and then that is just a number. So there's my answer right there. 2x squared minus 5x plus 6. All right, second example. You notice we have our little thought bubble here, and the reason we have our thought bubble is if you notice, this goes 4 to 2. Are we missing a 3? Yes. So we need a placeholder. Okay? So, how do we do that? Just like we talked about. We're going to write our coefficients. Well, if we don't have an x to the third term, what is the coefficient of x to the third? 0. I hope everybody was thinking 0 because that's what it is. 1, 0, -10, -2, and 4. Again, I'll just rewrite them up here real quick. 1 was the coefficient of x to the fourth. 0 is the coefficient of x to the third. Again, remember, x to the third is not there, so we need a placeholder. -10 is the coefficient of x squared. -2 is the coefficient of x. And 4 is the constant, okay? What goes in the little box there, remember, is the solution. So you have x plus 3 is equal to 0. I'm going to subtract 3 on both sides. I get x is equal to -3. So the solution is going to go there. So that's -3, okay? And now we can start our algorithm. So the first thing that we have to do is bring down that first coefficient. Okay, now once we have a number underneath that line, we are now going to multiply those two things together, right? And once we multiply them, what is that? -3 and 1. We're going to place it underneath the next coefficient. After we do that, we are going to add these two together. And when we add those together, we get -3, right? All right. And now since we have another number underneath the line, we're going to multiply. So -3 times -3 is +9. That +9 goes right there. We are then going to add those coefficients together. I would get -1, right? Unholy cow. Do we have another number underneath the line? Yes. So the algorithm starts over. -3 times -1 is +3. So that number goes underneath my coefficient. So -2 plus 3 would be 1. And -3 times 1 is -3. If I added those together, that would be 1, yes? Okay, so I know this guy right here is my remainder, okay? So again, these are the coefficients of my answer. I need to know, what do I start with, right? What degree do I start with? Well, if I started with x to the fourth and I divide by x to the fourth divided by x is equal to x to the third. So I would have 1 x to the third minus 3x squared minus x plus 1 over x plus 3. All right, for the last one, I want you guys to pause the video, try it yourself, and then obviously when you get done, play the video and see if you have the right answer. All right, I'm assuming all of you got to this point, which is awesome, right? We had 4, -6, and -4 as coefficients, and then 3 as the remainder. There is something I want you to take a look at, which is this. If you ever have a fraction that you are dividing by, or what's in that half square there, guys, what you're going to do, because it doesn't make sense, right? If we were doing this by long division, if you look at this, you would say, what do I need to multiply 2x by to get to 2x to the third? And you know that's 2x squared, right? Well, synthetic and long division are the same thing, the same process, so you should get the same answer. But if you look here, you do not, right? And the reason is because this is a fraction, okay? So the only thing that we have to do, since we're dividing by 2 here, we have to make sure we divide every one of these coefficients by 2 as well. Do not divide remainder by 2. Divide. Okay, do not divide remainder by 2. So then your answer then should be 2x squared, and that's exactly what we got here, right? 2x squared minus 3x minus 2 plus 3 over 2x minus 1.